YouTube channel, and I'm back with another video. Let me check the sound input. Okay, let me reset. So in this video we are going to cover the second topic of HLD in our HLD course, which is we've covered the introduction, which we have seen the overview of what system designing is. System designing was architecture of the system and its component. There are two types of system designs. One is high level design and the second is low level design. In chronological order, HLD comes first, then comes LLD. We've also seen the difference between HLD and LLD. HLD was less technical, LLD was more technical. HLD only included the main or prime components of your system, but LLD included detailed analysis, detailed technicalities of all the components mentioned in your HLD. The input of HLD is SRS, which is System Requirement Specification Report, and the input of LLD is HLD, Reviewed and Detailed HLD. So now moving on to the second important thing, which is architecture style. So we have seen that system designing, now all these rest of the videos are all based on HLD. So this first was based on the difference between HLD and LLD. And in the second video we are going to cover the type of architecture, which is how our system will be built. So there are generally two types of architectural styles. One is distributed and another is monolithic. So we want to cover that. And microservices. So we have two architectural patterns that can be applied to our application. One is monolithic, one is distributed. And microservice, this is a type of distributed system. Monolithic means all your code, everything is on a single system, but microservice, which is a type of distributed, means that it is on distributed on multiple computers. So monolithic is one kind of architecture, while microservice is another kind of architecture pattern, and both of these patterns have their own advantages and disadvantages, and their usage depends on the use case. So if we are developing a new application completely, then we can start with monolithic. If that application is small, if we don't want it to be scalable, if the number of customers is less, if we have less resources, then we can develop a monolithic architecture. And then also we can sometimes first develop monolithic, then we can slowly graduate to the distributed architecture like microservice. So what is microservice architecture? A microservice architecture means we have, what is the need of a microservice? Firstly, what is the need of distributed? So we have learned in solid principles that we want our system to be loosely coupled, because loosely coupled helps us make our system flexible, scalable, and it is also extensible, because once it is loosely coupled, we can make changes without making changes to other components also. If we want to make changes to one service, we don't have to modify other services also, they will remain unaffected. So microservice architecture is that distributed architecture where we have small and targeted and independent services which are loosely coupled, and each service is independent, that is, each service has its own responsibility, own separate code base, can be deployed independently, and each service is responsible for single business responsibility within a bounded context. So we have also seen that in solid principle, S stands for single responsibility, means every class has only a single responsibility, means it should have only one reason to change. Whereas O was open and closed, means it should be open for extension but closed for modification. Interface segregation means there should be interfaces everywhere. And L was Liskov substitution, every parent class should be replaceable with a subclass. And D was dependency. That means that the high level module and the low level module should be replaced. There should be an interface, they should not directly interact with each other. So that was dependency inversion. So single responsibility, open close, Liskov, interface segregation, and dependency inversion. And interface was that the clients should not be forced to depend on methods they do not use, so therefore should be interfaces, and interfaces should be small. And we have also seen two of the important patterns like Yagni, which is you ain't gonna need it, means don't implement it till you are not going to need it, and Dry, which is do not repeat yourself. And the third is keep it simple and stupid. So these are some of the good design principles, and then we have design patterns. So microservice means it is small, it is independent, single code base, independent code base, deployable independently, and it has only single responsibility. So for example, here you can see that there is a client, there is an API gateway, because the client is going to send a request, and that is an API gateway which maps it. Now it will map it depending upon the API to either which of the service the user has requested, and that service might contact or interact with another service. So everything is divided into services. Example of a microservice architecture in cab booking application. So let's imagine that you are building a cab booking application like Ola that plans the trip requested by passenger, provides them with a driver, accepts payment from passengers, and sends them notification. So this application will consist of several components including passenger management, driver management, trip management, payment management, billing, and notification services using observer design pattern. So these services will communicate to each other via API gateways and will collectively serve the purpose of the cab service, and every service is going to be independent, single responsibility, loosely coupled, and independently deployable, and they are going to be small and targeted. So what is the advantage of microservice? So obviously scaling, because you can scale your system, that needs additional resources without scaling your entire application, because services can be scaled independently. For example, one of the service like payment gateway, payment service, that requires more computation, you can scale it independently, you don't have to scale the entire system. Loose coupling, so bug fixes, feature release, adaptations, and future modifications, and they can be simpler to handle because it is more flexible. Microservices are distributed independently. Multiple tech stack, so a team can pick the technology that fits the best for their service, therefore resulting in a mix of technology stacks for different services. And fault isolation, so if there is any bug in the system, then they can easily isolate that bug from which service it is coming, and then they don't have to do complete system bug testing, or they don't have to debug the complete system. They can debug that independent service only. To properly handle failures, a particular microservice goes faulty won't affect the entire application. And there are some other techniques also that we have for fault tolerance, improving fault tolerance, which we will discuss later. What are the disadvantages of microservice? Obviously network congestion. For example, the use of small granular services, they will have to do all the interactions through inter-service communication, and which will result in very high latency sometimes. And if that system is not, the HLD is not modular enough. And security, so a frequent deployment of microservices across many cloud environments increases the risk and reduces the control and visibility over your application components. And the testing phase is also complex because the integrated system is difficult to test, because there are separate independent so many pieces. So the complete system, entire system testing and the integration testing is going to be a little complex, and it is also going to be costly because the total system has more moving components. Because of microservice architecture will add cost. Only if the expense of fully adopting microservice can be amortized across dozen of development teams, it will be worthwhile. So if the cost meets revenue, then only we should opt for microservice architecture. What is the difference between monolithic and microservice architecture? So monolithic means there is only one code base. There are multiple components in the same code base only, and the business functionalities are also in the same code base. Microservice architecture means individual services, independent services, small services, loosely coupled services, and independently deployable services, with each service which is single responsibility, means it is only responsible for a particular functionality or task. Monolithic means it is very simple to implement, it doesn't require any domain knowledge of development. But microservice can be risky to implement if the team does not have domain expertise and container knowledge. Monolithic architecture is very easy to deploy, whereas microservice is complex to deploy, because you have to deploy every independent service separately. Monolithic means updating the system in a tedious process which would need the entire system to be redeployed. But agar microservice may any one service is faulty or it has been updated, we can just deploy that particular service again, so we don't need to deploy the complete service again. And also in microservice we use dockers, where we have images of each service, we deploy each service we want to run on Docker. But monolithic is just an entire system running on a particular machine, and in monolithic we reuse the modules from one software into another is difficult, but microservice is flexible and it is reusable. Thank you.